The battalion quartermaster spread ammunition tallies across a folding table while dawn mist clung to the broken terraces. Above him, German Fallschirmjäger held the abbey. Below, mule trains waited for darkness that would not come soon enough. A young corporal penciled routes over a captured Italian map, tracing paths too narrow for trucks, too steep for jeeps. Commanders had expected supply by pack animal and limited night convoy. The reality of arriving in battalion war diaries told a different story. 72 sorties in 24 hours, all tracked, all small, all indispensable. The vehicle making those climbs weighed 3 tons, carried 85 horsepower, and bore a designation most planners had once dismissed as auxiliary. By February 1944, it had become the primary artery of the 8th Army's advance. This is the story of the Universal Carrier, the light-tracked vehicle that redefined infantry mobility and became the most produced armored fighting vehicle in British military history. The design board at Vickers Armstrong showed the essentials of tracked mobility reduced to first principles. 2 men. Light armor plate. Tracks barely wider than a man's shoulders. The trial notes from Woolwich emphasized what the interwar British Army valued most after the Great War's static nightmare: movement and cost-effectiveness. The Carden Lloyd Mark VI tankette had proven the concept in colonial service, but its limitations were equally clear. Too cramped for sustained operations. Too lightly armed to fight. Too specialized to justify mass production. British military planners in the mid-1930s expected armored decisions to come from 2 sources: fast cruiser tanks for exploitation and heavy infantry tanks for breakthrough. Light-tracked vehicles occupied a category the War Office termed ancillary. Useful but not essential, supporting but not decisive. The expectation was clear. Real armor would win battles. Light carriers would follow behind, ferrying supplies and wounded. Reality took a different path. The War Office Mechanization Board, reviewing the lessons of 1918 and studying reports from Spain, identified a persistent gap in infantry operations. Rifle companies advancing under fire needed mobility for their heavy weapons, machine guns, mortars, anti-tank rifles, but organic transport did not exist. Trucks required roads. Horses required fodder and broke under shellfire. Carrying a Vickers machine gun by hand meant exhausting 6 men before the weapon ever fired. The solution emerged from Vickers Armstrong's engineering offices in 1936. A universal chassis capable of carrying a Bren light machine gun team, or a Boys anti-tank rifle section, or a 3-inch mortar crew or stretchers or ammunition. Designated initially as the Bren Carrier, then the Scout Carrier, and eventually standardized as the Universal Carrier, the vehicle adopted a deceptively simple configuration. An 85-horsepower Ford side-valve V8 engine, identical to civilian automobile power plants, provided propulsion. A 4-speed gearbox and final drives optimized for short, high-torque movements gave the vehicle quoted road speeds of 30 miles per hour, with practical cross-country performance of 15 to 20 miles per hour. Weight stayed in the 3-ton class. Armor protection ranged from 7 to 10 millimeters, sufficient to stop rifle rounds and shell fragments, inadequate against dedicated anti-tank fire. The specification documents filed with the War Office in 1936 described the function with bureaucratic clarity. Transport under fire of crew, light weapons, ammunition. Combat is not primary. This was not a tank. It was not intended to fight enemy armor or assault fortified positions. It was a battlefield taxi, designed to keep infantry moving when movement meant survival. By reducing armor thickness and standardizing automotive components with commercial suppliers, Vickers Armstrong created something more valuable than a fighting vehicle. They created a producible system, simple enough to manufacture at scale, simple enough to maintain in the field, simple enough to train crews in weeks rather than months, and simple enough to ship by the thousands. The first production contracts arrived in 1937. Initial orders specified modest numbers, typical for a support vehicle. The War Office anticipated equipping reconnaissance platoons and carrier platoons in infantry battalions, perhaps 2,000 vehicles to outfit the regular Army and territorial divisions. Production began slowly, constrained by peacetime budgets and competing demands for rearmament funding. Then came September 1939. When Britain declared war on Germany, the Army fielded 2,812 carriers. a number that appeared adequate for the forces then mobilized. Within 6 months, that number would prove catastrophically insufficient. The rapid expansion of the British Expeditionary Force, the mobilization of Commonwealth divisions, and the early campaigns in France revealed a stark truth. Modern mechanized warfare consumed vehicles faster than any pre-war planning had anticipated. The small tracked utility vehicle, designed as an afterthought to support infantry operations, began its transformation into the logistical backbone of British and Commonwealth ground forces. The factories that built them, scattered across Britain, would soon multiply across 3 continents. The Ford V8 engine that powered them would become as critical to Allied operations as the Rolls-Royce Merlin. And the designation Universal Carrier would acquire a meaning beyond its technical specifications. It would come to represent the unglamorous, essential work of keeping infantry alive and moving in a war where mobility meant everything. By the time France fell in June 1940, Vickers Armstrong and licensed manufacturers had delivered nearly 8,000 carriers. Hundreds had been lost at Dunkirk, abandoned on French beaches or destroyed during the evacuation. The losses clarified a brutal equation. Armies needed carriers faster than factories could build them using traditional methods. The solution required industrial mobilization on a scale Britain had never attempted, and participation from allies who could turn automotive mass production into armored mobility. The little vehicle with the civilian engine was about to become the most widely produced tracked fighting vehicle in Commonwealth service, outnumbering every tank design, every self-propelled gun, every specialized armored vehicle the British would field in the Second World War. It achieved this distinction not through superior firepower or heavy armor, but through relentless utility and absolute dependability. Where tanks fought, carriers sustained. Where trucks failed, carriers persisted. And where infantry walked alone, carriers ensured they walked no more. The Ministry of Supply faced a problem of arithmetic in late 1939. British tank production struggled to reach 100 vehicles per month. Carrier demand exceeded 200 per month just to equip formations already mobilized. Expanding existing factories offered incremental improvement. The real solution required industrial replication across the Commonwealth. The expectation before the war held that armored vehicle production demanded specialized facilities, skilled labor, and complex tooling that could only exist in established British arsenals. Reality proved otherwise. The carrier's simple design, commercial automotive components, straightforward armor plate fabrication, and standardized track assemblies made it ideal for distributed manufacturing. Within months of war's outbreak, Ministry of Supply engineers packaged complete technical drawings, jigs, and specifications into circulars dispatched to Canada, Australia, and New Zealand. Ford of Canada received the first package in December 1939. The Windsor plant, experienced in automotive mass production, adapted existing assembly lines for military use. By March 1940, Canadian-built carriers began rolling off production lines at a rate of 3 vehicles per 8-hour shift. The transformation took 12 weeks, a time frame that would have been impossible with more complex armored designs. The key lay in the 85-horsepower Ford V8 engine. Ford facilities in North America already manufactured identical power plants for civilian vehicles. Transmission components, final drives, and suspension systems required modest modifications but used the same production techniques as automobile manufacturing. Armor plate fabrication demanded new equipment, but local steel mills and shipyards possessed the necessary rolling and cutting capacity. Track assemblies followed standardized dimensions that allowed multiple suppliers to produce interchangeable components. Ford of Canada installed 3 engines at a time, synchronized the drivetrain assembly with armor hull construction, and integrated track mounting into a continuous flow process. By June 1940, monthly production reached 120 vehicles. By December, 200. The acceleration continued through 1941 and 1942, driven by expanding orders from Britain, expanding Canadian forces, and Lend-Lease requirements for Allied recipients. Australia entered production in July 1940. The state engineering works in Melbourne and private contractors, including General Motors Holden, adapted the British specifications to local materials and manufacturing capabilities. New Zealand followed with smaller-scale production focused on specialized variants. South African workshops assembled carriers from British and Canadian manufactured components. India prepared facilities for eventual production and major overhaul work. The production figures recorded in War Office statistical returns for 1942 documented an industrial achievement that contradicted every pre-war assumption about armored vehicle manufacturing. Britain produced approximately 57,000 carriers from 1936 through late 1942. Canada manufactured approximately 29,000. Australia and New Zealand combined contributed approximately 5,000. The cumulative total approached 91,000 vehicles by the end of 1942, a number that exceeded total British tank production for the same period by a factor of nearly 4 to 1. Labor requirements explained part of the disparity. Ministry of Supply estimates indicated each carrier demanded approximately 700 man-hours to manufacture, compared to roughly 7,000 man-hours for a Churchill infantry tank. Materials consumption similarly favored the carrier. Approximately 2 tons of armor plate steel, 1 Ford V8 engine, and standardized track units that could be produced by multiple suppliers without requiring custom tooling. A Ministry of Supply memorandum from 1942 captured the strategic logic with characteristic British understatement. A weapon of movement, not destruction, the carrier embodied a fundamental principle that would define Allied logistics throughout the war. Mobility multiplied combat power more effectively than additional armor or heavier guns. A battalion with 12 carriers possessed far greater tactical flexibility than a battalion with 2 additional tanks. The tracked utility vehicle enabled dispersal, rapid redeployment, sustained fire support, and reliable casualty evacuation, capabilities no tank could provide while simultaneously engaging enemy armor. Decentralized manufacture offered additional advantages beyond raw numbers. Geographic distribution hedged against German bombing campaigns that targeted concentrated industrial facilities. Multiple production sources ensured steady spare parts flow even when shipping routes faced interdiction. Identical drivetrains from Britain, Canada, and Australia meant maintenance crews could work on any carrier regardless of manufacturing origin, simplifying training and reducing logistics overhead. The contrast with German armored vehicle production grew stark through 1942. Germany manufactured approximately 4,000 tanks and assault guns in 1942, less than the monthly carrier production from Commonwealth facilities at peak output. German light tracked vehicles, including the SDKF Z250 series half-track, required more specialized manufacturing and consumed resources needed for tank production. No German equivalent to the carrier existed. The Wehrmacht relied on trucks for infantry mobility and rarely achieved the all-terrain persistence Commonwealth forces accepted as routine. By late 1942, Allied forces fielded more tracked light utility vehicles than Germany possessed tanks. The numerical disparity represented more than industrial capacity. It reflected fundamentally different approaches to mechanized warfare. German doctrine concentrated armor into elite divisions expected to achieve decisive breakthroughs. Commonwealth doctrine dispersed armor across infantry formations, prioritizing sustained mobility over concentrated striking power. The little 3-ton vehicle with the civilian engine had become an instrument of operational art. Where German infantry walked, often accompanied by horse-drawn carts, Commonwealth infantry rode under armor. Where German supply trains stalled at destroyed bridges and cratered roads, carriers crossed obstacles and continued forward. The asymmetry did not show in tank versus tank engagements, it manifested in battalion-level operations, in casualty evacuation times, in artillery ammunition expenditure rates, and in the grinding persistence of infantry advances that never quite stopped moving. A year in which Germany built 4,000 tanks coincided with Commonwealth production of tens of thousands of carriers. Armored mobility was outpacing armored firepower, and the implications would reshape every campaign from Sicily to Burma. The vehicle most planners had once dismissed as auxiliary had become the foundation of Allied infantry capability. Production supremacy in a 3-ton class carrier translated into operational supremacy across theaters where terrain, weather, and distance reduced armored warfare to a contest of logistics and endurance. The factories that built carriers, Birmingham, Windsor, Melbourne, and dozens of smaller facilities, operated as part of an integrated industrial system that could lose individual plants to bombing and still maintain output. They represented decentralized resilience that complemented the vehicle's mechanical simplicity. Together, industrial mobilization and simple design created a weapon system that answered the most basic question of modern war: how to keep infantry moving when everything else stopped. An operations officer in 8th Army headquarters stood before a road map of Sicily in July 1943 and methodically marked each collapsed bridge with a red grease pencil. The German rearguard demolition program had been thorough. Main supply routes showed red marks every 5 to 10 kilometers. Secondary roads fared worse. The officer set down the pencil and studied the pattern. Every route suitable for truck convoys or tank movement had been cut. Mule paths climbed where roads ended, too narrow for wheeled vehicles, too steep for heavily armored tanks. Allied planners preparing for the Sicily invasion had anticipated German demolitions but expected medium and heavy armor to punch through to Messina within 2 weeks. The plan assumed roads would be damaged but passable, bridges reparable by Royal Engineers within hours, and terrain generally favorable to mechanized advance. Reality confronted these assumptions within 48 hours of landing. Mount Etna's volcanic slopes and Sicily's mountainous interior created terrain that negated every advantage Allied armor possessed. Sherman tanks bogged in volcanic ash on gradients too steep for sustained climbing. Churchills through tracks on sharp hairpin turns where road surfaces crumbled under their 20-ton weight. Trucks required graded roads and functioning bridges, resources German engineers had systematically destroyed during their retreat. The German 15th Panzergrenadier Division and Hermann Göring Division conducted a fighting withdrawal designed to exploit Sicilian geography. Every demolished bridge forced Allied columns to halt while engineers surveyed, cleared mines, and constructed bypasses. Every destroyed viaduct added hours or days to advance timelines. The delays accumulated, transforming what planners had envisioned as a rapid pursuit into a grinding advance measured in kilometers per day. Into this gap stepped the universal carrier. Battalion commanders discovered what engineers and supply officers already knew. The 3-ton tracked vehicle could traverse terrain that stopped everything else. Narrow mountain paths barely 1 vehicle wide. Steep gradients exceeding 20 degrees. Rocky streambeds and terraced vineyards. Demolished bridges that left gaps too wide for trucks but narrow enough for carriers to pick their way across rubble or ford shallow crossings. The vehicle's low ground pressure weight distributed across tracks rather than concentrated on wheels allowed it to cross surfaces that would collapse under heavier vehicles. 8th Army and 7th Army units began adapting their tactics to available mobility. Rifle companies that normally assigned carriers to platoon heavy weapons sections began using them as primary transport for everything. 3-inch mortar teams and their ammunition. Vickers medium machine gun crews. KAT anti-tank teams. Battalion signal sections with number 18 and number 19 wireless sets. Medical orderlies with stretchers. Combat engineers with demolition charges and mine detectors. Supply runs forward carrying rations, water, and small arms ammunition. Return trips evacuating wounded who would otherwise wait hours or days for mule trains. War diaries from British and Canadian units recorded the shift with factual precision. A typical entry from the 1st Battalion, Seaforth Highlanders noted, Carrier platoon conducted 14 resupply runs. Forward dumps established 3,000 yards beyond truck head. All forward movement by tracked vehicles only. Another entry from the Royal 22nd Regiment documented. Casualties evacuated by carrier. Road impassable to ambulances. Stretcher bearers would require 6 hours descent. The carrier completed the run in 45 minutes. Italian civilians witnessed something they had not seen during their own army's operations. British infantry advancing with track transport continuously present. German rearguards, accustomed to severing Allied mobility by destroying bridges, found Commonwealth units continuing forward despite demolished infrastructure. The tactical impact accumulated across dozens of small engagements where artillery support, ammunition resupply, and casualty evacuation made the difference between successful attacks and stalled assaults. The terrain that stopped Allied tanks made carriers indispensable. Sicily's campaign demonstrated this principle. The invasion of mainland Italy in September 1943 proved it beyond doubt. The Italian mainland presented even more challenging geography. The Apennine mountain range forms Italy's spine, creating parallel valleys that run roughly north-south while roads struggle east-west. Villages perched on hilltops required access via winding roads easily defended and readily demolished. Rivers, though rarely deep, flowed through gorges that confined bridges to narrow stone structures dating from Roman times. Structures German engineers blew methodically as they withdrew. British and Commonwealth divisions advancing up the Italian peninsula encountered a pattern that repeated every 10 to 20 kilometers. A demolished bridge, a defended hilltop village, cratered roads, and terrain that channeled movement into predictable kill zones. German forces, initially the 10th Army, later augmented by the 14th Army, fought a defensive campaign that leveraged Italy's geography to offset Allied material superiority. Carrier utilization expanded from tactical expedient to operational necessity. Battalion establishments in Italy increased carrier allocations to 10 to 12 vehicles per rifle company, creating a de facto tracked logistics network that functioned independently of divisional truck transport. Carrier platoons operated as shuttle services synchronized to artillery fire plans, moving forward during bombardments when German observers took cover, then shifting laterally to avoid predictable return fire. Royal Engineers field companies fitted carriers with specialized equipment for Italian operations. Bangalore torpedo racks for clearing wire obstacles. Satchel charges stowage for bunker assault teams. Additional wireless sets to maintain communications in mountainous terrain where line-of-sight radio propagation rarely exceeded 2 kilometers. Stretcher frames that secured casualties for transport over rough terrain. Smoke grenade launchers for screening movements across open ground. An 8th Army after-action report from December 1943 summarized the transformation with unusual frankness. Tracked light transport remains the only practical means of forward supply beyond artillery range. The vehicle, initially classified as auxiliary to operations, has become essential to sustained offensive action. Recommend increased establishment and priority shipping allocation. The auxiliary vehicle had become the main artery. The light-tracked utility vehicle designed to support heavy tanks had proven more operationally relevant than the tanks themselves in terrain where armor could barely maneuver. Italy, a country that stopped tanks, ran on carriers. The implications extended beyond Italy. Planners preparing for Northwest Europe studied the lessons and increased carrier allocations for invasion forces. Formations training in Britain emphasized carrier integration during infantry armor cooperation exercises. Production schedules accelerated to meet expanding demand. The vehicle that began the war as a specialized item in limited service had become ubiquitous, so common that soldiers stopped remarking on its presence and noticed only its absence. By the end of 1943, more than 60,000 carriers operated across all theaters. Italy alone absorbed 7,000. Each one represented mobility that could not be obtained any other way, logistical capacity that enabled operations otherwise impossible, and tactical flexibility that transformed infantry from footbound formations into mechanized forces capable of sustained offensive action in the worst terrain the war would offer. The next test would come at Cassino, where terrain even more brutal than Sicily would push carrier operations to their absolute limit, and prove once and for all that small vehicles could carry an army up a mountain the hard way. The monastery of Monte Cassino dominated the Liri Valley from 1,500 feet elevation, its medieval walls converted into German observation posts that made daylight movement suicidal for anything larger than a man on foot. Below the abbey, German Fallschirmjäger, paratroop infantry among the Wehrmacht's finest, occupied positions carved into the mountainside. Between the German positions and Allied lines, a chaotic terrain of shattered terraces, collapsed buildings, and shell-cratered slopes defied conventional military movement. 1st Battalion, Royal Fusiliers held positions on the lower slopes, tasked with maintaining pressure on German defenses while larger forces prepared for set-piece assaults. The battalion quartermaster faced calculations that revealed the arithmetic of mountain warfare. A rifle company firing in support of an attack consumed roughly 1,200 pounds of small arms ammunition per day, belts for Bren guns, boxes for Vickers medium machine guns, mortar bombs for 3-inch tubes. Add rations for 120 men, water for a day's consumption in Mediterranean winter cold, medical supplies, wireless batteries, smoke grenades, and replacement equipment. The total approached 2 tons per company per day. Doctrine assumed mule trains and limited jeep lifts during nighttime lulls in shelling. Reality at Cassino permitted neither. German artillery fire interrupted trails during darkness. Mules, already scarce after months of attrition, could not climb the steepest approaches. Jeeps bogged in shell craters and lacked traction on rocky surfaces. The supply line that should have sustained 4 companies reached barely 1. Carrier section commanders studied the problem with the practical fatalism of soldiers who understood their options had narrowed to 1. The tracked vehicles could climb. They could cross terrain that stopped mules. They carried more than man-packing, and their armor, thin as it was, stopped shell fragments that killed men and animals outright. The 1st Battalion War Diary for 15 through 16 February 1944 recorded 72 carrier sorties in 24 hours. Each sortie meant a loaded vehicle grinding up slopes in darkness or during brief artillery pauses, nosing through rubble of destroyed buildings, pivoting on narrow terraces barely wider than track width, and reaching forward positions that saw no other mechanical transport. Typical load per vehicle approximated 1,200 pounds, bomb boxes, ammunition crates, water cans, medical panniers. Forward dumps, replenished every night, sustained mortar and machine gun fire that pinned German infantry and covered engineer work on demolition obstacles. The return trips carried stretcher cases. 4 men could fit if they lay still. 6 if desperation demanded. Medical orderlies strapped casualties to improvised frames welded to hull tops or lashed stretchers across engine decks. The wounded rode exposed, but they rode. The alternative meant 12 hours waiting for darkness and stretcher-bearer teams that might or might not reach aid stations before shock and blood loss became irreversible. German observers noted the persistent tracked movement and adjusted artillery fire accordingly. Carrier crews responded with tactics learned through attrition. Never use the same route twice in succession. Move during Allied bombardments when German spotters sheltered. Sandbag front glassy plates to increase protection against shell fragments. Stow ammunition in external nets rather than inside the crew compartment. If fire broke out, better the cargo burned than the crew. Paint vehicle numbers with mud to prevent identification across multiple sorties. New Zealand Corps, coordinating operations on the valley floor, received daily carrier movement summaries from forward battalions. The reports documented a logistics system operating at capacity. 8 hours running per vehicle per day. Typical 25 miles covered over terrain that reduced mechanical road speeds to walking pace. 30 gallons of fuel consumed, replenished from jerry cans man-carried forward by supply personnel. Track life extended through field expedients. Flipping worn pins, welding cracked links, cannibalizing damaged vehicles for spare assemblies. The technology that made casino operations possible had been designed for cross-country mobility, not mountain warfare. Low ground pressure distributed weight across track surfaces, allowing the carrier to traverse slopes where wheeled vehicles lost traction. Narrow track width, barely 5 feet, permitted maneuvering through rubble and collapsed structures. Compact length meant tight radius turns on terraces cut into hillsides. The 85 horsepower Ford V8, though modest by military standards, provided sufficient torque in low gear to climb gradients exceeding 25 degrees with load aboard. A Royal Engineers lieutenant, documenting carrier movements for after-action analysis, recorded a detail that captured the vehicle's role. Carriers alone could ascend the lateral terraces under fire. No alternative existed. Failure to maintain flow would halt operations within 48 hours. The persistent small vehicle traffic achieved effects beyond simple tonnage delivered. Sustained machine gun and mortar fire fixed German positions, preventing reinforcement and limiting counterattacks. Artillery forward observers reached positions with clear sight lines, improving fire direction accuracy. Medical evacuation reduced casualties lingering in forward positions, maintaining unit morale. Engineers received demolition supplies for bunker reduction work. Signal personnel maintained communications through wireless sets that required battery replacement every 36 hours. The mathematics of casino supply reduced to carrier loads per hour. A company needed roughly 50 loads per day to sustain full combat operations. Battalion carrier platoons possessed 12 to 15 vehicles, meaning each vehicle ran 3 to 4 sorties daily. Maintenance time, loading time, and crew rest consumed additional hours. The system operated at maximum sustainable tempo with minimal reserve capacity. When a carrier threw a track, bogged irretrievably, or took direct artillery hit, Replacements came forward from battalion reserves. When reserves depleted, divisional pools provided vehicles. When divisional pools ran low, corps-level stocks released additional carriers. The prioritization reflected battlefield reality. Casino consumed tracked utility vehicles faster than any previous operation in the Mediterranean theater, and operations ceased when carrier flow stopped. The decisive artillery at Casino, despite massive bombardments from Allied heavy guns, proved to be delivered, measured in carrier loads per hour, tons accumulated in forward positions, and rounds available when infantry assault required fire support. The monastery stood unbreached through February, March, and into May, but the supply line that crawled up the mountain never stopped moving, and in the arithmetic of sustained operations, persistence mattered more than breakthroughs. The German defense held through winter not because Allied forces lacked firepower, but because terrain restricted logistics. The universal carrier, operating at the absolute limit of mechanical possibility, ensured that restriction never became prohibition. A Royal Electrical and Mechanical Engineers fitter stood in a forward repair post 40 miles behind the Italian front line, timing an engine swap with a pocket watch. The old Ford V8 came out in sections. Radiator, exhaust manifolds, motor mounts, bell housing. 70 minutes elapsed. The replacement engine went in, following the manual sequence exactly. Cooling system connected. Fuel lines attached. Electrical connections secured. Total time, 1 hour 53 minutes. The fitter made a notation in the workshop log. Carrier number 478 returned to service. Engine swap completed within tolerance. The scene repeated across every theater where Commonwealth forces operated. North Africa, where sand infiltration degraded engines in months rather than years. Italy, where mountain operations ran power plants at maximum load for hours daily. Northwest Europe, where winter cold strained starting systems and summer heat stressed cooling capacity. Burma, where tropical humidity corroded electrical systems and fuel contamination caused persistent carburetor problems. Commanders had feared that heterogeneous vehicle fleets would immobilize formations when spare parts ran low or specialized repair capabilities proved unavailable. The Royal Army Service Corps and Royal Electrical and Mechanical Engineers maintained extensive logistics chains for tank engines, distinct power plants for cruiser tanks, infantry tanks, light tanks, and American-supplied Shermans. Each engine type demanded unique maintenance procedures, specialized tools, and dedicated spare parts inventory. The multiplication of incompatible systems created vulnerability. Lose access to the right spare parts, and entire tank units became immobile. Reality with carriers took a different path. The Ford side-valve V8 engine that powered virtually every universal carrier in Commonwealth service, British-built, Canadian-built, Australian-built, shared fundamental architecture with civilian automobile engines produced since the mid-1930s. The standardization meant multiple sourcing, simplified training, and redundant supply chains that could lose individual components without halting operations. The engine's technical profile reflected commercial automotive priorities. Reliability, ease of maintenance, parts commonality, a 3.9-liter displacement, producing 85 horsepower at approximately 3,800 revolutions per minute. Side valve configuration with flathead combustion chambers, simpler to manufacture than overhead valve designs, more tolerant of low-octane fuel, easier to service in field conditions. Cast iron block construction that resisted damage from rough handling. Water cooling with straightforward radiator systems. Electrical ignition using standard 6-volt batteries and commercially available spark plugs. Final drive gearing optimized the engine's output for military requirements. Civilian automobiles prioritized highway cruising. Carriers demanded torque for hill climbing and cross-country movement. Gearbox ratios favored low-speed pulling power over maximum velocity. The result? Practical cross-country speeds of 15 to 20 miles per hour, climbing ability up to 25-degree gradients with load, and fuel consumption that averaged 1 to 1.5 miles per gallon under combat conditions. War Department maintenance summaries for April 1944 documented operational availability rates that contrasted sharply with other armored vehicles. Italian theater units reported carrier operational downtime below 6%, meaning that in any given battalion, one vehicle in 20 sat immobile awaiting repair at any moment. Compare this with German armored returns from the same period. Panzer IV and STUG assault gun units listed 24 to 30% non-availability from mechanical and terrain causes. The disparity reflected more than superior British engineering. German armored vehicles used more complex power plants, heavier armor that stressed drivetrains, and specialized components that required factory-level repair when damaged. Carriers used commercial engines with proven field repair procedures, light armor that reduced mechanical stress, and standardized parts available from multiple suppliers. Track life exemplified the maintenance philosophy. Carrier tracks used simple pin-and-link construction that field mechanics could service with basic tools. Worn pins could be flipped to extend service life. Cracked links could be welded or replaced individually. Complete track assemblies, though consumed rapidly in mountain operations, shipped as modular units that required no special tooling to install. A battalion could maintain operational readiness by cannibalizing damaged vehicles for spare tracks, consolidating parts inventory, and cross-leveling assemblies among vehicles. The archive of the War Office contained a memorandum from April 1944 that summarized maintenance doctrine with characteristic British understatement. Standardization of automotive spares continues to yield outsize effect in forward maintenance. The Ford V8 powertrain, replicated across Allied production, permits rapid engine changes, simplified inventory management, and reduced technical training requirements. High mean time between failure and fast repair cycles convert a light vehicle into a reliable logistics constant. That last phrase, reliable logistics constant, captured the carrier's operational value. In mechanized warfare, availability mattered more than peak performance. A vehicle that ran 85% of the time outperformed a vehicle twice as powerful that ran 60% of the time. Consistency beat capability when campaigns lasted months and supply lines stretched thousands of miles. The same engine architecture found in civilian sedans before the war kept Allied divisions mobile in the Apennines, supplied battalions on Burmese jungle tracks, and ferried wounded across North African deserts. The commercial power plant, designed for suburban commuters and rural delivery vehicles, proved remarkably adaptable to military requirements when paired with appropriate gearing and track systems. Ford's original engineers, developing the side-valve V8 for the mass automobile market, had created something unintended, a military logistics solution that would outlast the war and continue service in dozens of armies for decades afterward. By April 1944, more than 100,000 carriers operated worldwide, and virtually everyone shared the same basic power plant. The logistical implications staggered analysis. A single spare parts pipeline served vehicles operating from Burma to Belgium. Mechanics trained on one carrier could service any carrier. Fuel specifications remained constant across theaters. Maintenance schedules synchronized regardless of manufacturing origin. The doctrine of simplicity, embodied in a 3.9-liter commercial engine, had produced strategic mobility through tactical reliability. The small vehicle with the ordinary power plant had become extraordinary precisely because it remained ordinary, common, predictable, fixable, and above all, present. Where complexity failed and sophistication broke down, the universal carrier kept moving, powered by the same engine that had once carried salesmen to rural appointments and families to Sunday services. War revealed that the greatest military technology sometimes wore civilian clothes. The Anzio beachhead, established by Allied amphibious assault in January 1944, had become a nightmare of static warfare by May. German forces, reacting with characteristic speed, contained the landing within weeks and subjected the beachhead to sustained artillery bombardment. The perimeter, roughly 15 miles wide and 7 miles deep, held 36,000 British and 100,000 United States troops in ground so contested that frontline positions sat within direct observation of German artillery spotters. Carriers nosed through shell craters that morning, their tracks finding purchase in mud churned by months of bombardment. A Royal Engineer section loaded satchel charges and Bangalore torpedoes into the crew compartment of one vehicle. Another carried a PIAT anti-tank team forward to positions where German self-propelled guns probed Allied defenses. A third ferried medical supplies to an aid station that trucks could no longer reach safely. Planners preparing the Anzio operation had anticipated short-haul jeep resupply within the beachhead perimeter. Roads, though damaged, should remain passable. Supply dumps, positioned near the beach, should feed forward units through conventional truck convoy. Casualty evacuation should follow standard procedures. Stretcher bearers to battalion aid posts, ambulances to field hospitals. Reality imposed by German artillery fire made those assumptions obsolete within the first week. The beachhead's confined geography meant every road sat within range of German guns. Daytime movement invited immediate interdiction. Nighttime offered limited respite, but German harassment fire continued throughout darkness. Cratered ground and overlapping fire lanes forced vehicles into predictable routes that German artillery pre-registered for rapid engagement. Into this environment, the 5th Battalion Grenadier Guards discovered that the universal carrier became not merely useful but essential. Records noted carriers as the primary mobility asset for section weapons, a designation that reflected complete tactical integration. The vehicle that once supported infantry had become inseparable from infantry operations. Daily operations followed patterns driven by German artillery tempo. Carriers ran an average of 8 hours per day, covering roughly 25 miles of beachhead terrain. Short distances in linear measurement, substantial when translated to start-stop movement through cratered ground. Fuel consumption ran to 30 gallons per vehicle daily, supplied from forward dumps that themselves relied on carrier delivery. Carrier platoons operated as shuttle services synchronized to artillery pauses. German bombardment followed predictable rhythms. Intense fire at dawn and dusk, harassing fire during midday, concentrated barrages preceding counterattacks. Carrier crews learned to move during Allied artillery responses, when German observers took cover and counter-battery fire suppressed enemy guns temporarily. The technique meant careful coordination with artillery liaison officers, radio communication to confirm fire plans, and precisely timed departures that exploited brief windows of reduced interdiction. The vehicles adapted through field modification. Mortar carriers, originally designed to mount 3-inch tubes within the crew compartment, added external baseplates and stowage for bomb loads that exceeded original specifications. Machine gun carriers mounted Vickers .303 medium machine guns on improvised pintles that allowed traverse without dismounting. Stretcher racks, welded by battalion workshops, secured casualties for evacuation over rough terrain. Smoke pots, fitted to the hull rear, screened movement across open ground when artillery fire intensified. A typical carrier load at Anzio demonstrated the vehicle's versatility. Forward runs, ammunition in standardized wooden boxes, rations in sandbags to prevent breakage, water in 5-gallon jerry cans, replacement equipment in canvas packs, mail and personal items stuffed into available spaces. Return runs, stretcher cases secured by cargo nets, captured German documents for intelligence analysis, damaged weapons for rear echelon repair, and occasionally soldiers rotated off the line for brief rest. United States medical posts within the beachhead received Allied wounded evacuated by carrier when ambulances could not reach forward positions. The speed of evacuation, minutes rather than hours, reduced shock casualties and improved survival rates for wounds that would have proven fatal under slower evacuation procedures. Medical officers, initially skeptical of armored vehicles serving as ambulances, acknowledged that carrier evacuation saved lives conventional methods could not preserve. German artillery observers noted the persistent small track traffic in reports filed with 10th Army headquarters. The vehicles frustrated interdiction efforts precisely because they remained small, mobile, and numerous. Destroying one carrier removed a single vehicle from circulation. Another replaced it within hours. The tracked utility vehicles dispersed across the beachhead, presenting no concentrated targets worth major artillery allocation. They infiltrated routes deemed roadless, complicating defensive planning that assumed predictable Allied movement patterns. The psychological effect extended beyond material logistics. Infantry units that possessed adequate carrier support maintained morale through visible evidence that supply, reinforcement, and evacuation functioned despite enemy fire. Soldiers who knew wounded comrades would reach aid stations within minutes fought with greater confidence than those who understood evacuation meant hours of exposure. The small tracked vehicle, by its persistent presence, conveyed institutional commitment to supporting forward troops, a message that mattered as much as the ammunition it delivered. By May 1944, Anzio had consumed 8 months of continuous combat operations confined to terrain smaller than many peacetime military reservations. The beachhead had become a laboratory for infantry armor integration under extreme conditions. Lessons learned at Anzio informed planning for Northwest Europe, where mobile operations would demand even closer cooperation between infantry and supporting vehicles. The unit log entry that described carriers as primary mobility asset marked a doctrinal evolution completed through battlefield necessity. The vehicle designed to support infantry had become the means by which infantry operated. Where static lines appeared immobile, the carrier network made them quietly fluid, moving men, weapons, supplies, and wounded through fire that stopped everything else. The auxiliary had become essential, and the essential had become ubiquitous. No truck movement proved feasible after 0200 hours at Anzio. Carrier lifts became the assumption for all forward replenishment. The transition from doctrine to practice had occurred without formal policy change, driven entirely by soldiers adapting available tools to imposed conditions. The most effective military innovations often emerged exactly this way: necessity, improvisation, and eventual standardization of battlefield expedients that worked. A German staff officer filed a routine intelligence report at 10th Army headquarters, documenting observations from forward units engaged with British and Commonwealth forces. The Fremdheerbericht, Foreign Armies Report, served as the Wehrmacht's institutional memory system, capturing tactical details that might inform future operations. This particular report addressed a persistent challenge German infantry faced across the Italian theater: British tracked vehicles that appeared everywhere, infiltrated supposedly impassable terrain, and complicated defensive planning. The report opened with technical specifications compiled from captured vehicles and field observations. Armor thickness measured 7 to 10 millimeters, inadequate against dedicated anti-tank weapons, vulnerable to 20 millimeter cannon fire, but sufficient to defeat rifle-caliber rounds and shell fragments. Dimensions: length approximately 3.7 meters, width 2 meters, height 1.6 meters. Weight estimated at 3 metric tons combat loaded. Crew typically 3, though some variants carried only 2+ equipment. German intelligence designated the vehicle Brenntrager in early reports, then Universal Trager, as captured documents revealed official British nomenclature. Frontline soldiers used less technical terms: miniature panzer, English tracked vehicle, or simply the small tanks. The informal terminology reflected practical experience. These vehicles appeared where German doctrine assumed only dismounted infantry could operate. The expectation embedded in German defensive doctrine prioritized engaging actual threats: medium and heavy tanks, self-propelled guns, armored reconnaissance vehicles. Light track transports fell into a category the Wehrmacht termed non-combat vehicles, worth destroying if convenient, but not warranting dedicated anti-tank resource allocation. Doctrine assumed that demolishing bridges and cratering roads would force Allied infantry into predictable dismounted approaches, creating opportunities for concentrated defensive fire. Reality documented in June 1944 reports warned that British carriers infiltrate positions deemed roadless, arriving in sectors where German staff believed tracked movement impossible. Fallschirmjäger companies defending mountain positions noted carriers ascending mule paths at night. Gebirgsjäger mountain infantry units reported carriers crossing streams German engineers had dismissed as obstacles. Panzergrenadier formations conducting rearguard actions discovered British machine gun teams arriving by carrier rather than on foot, allowing them to establish positions before German forces completed defensive preparations. The tactical implications accumulated across hundreds of small engagements. German doctrine for delaying actions assumed time between Allied reconnaissance and assault, time for defenders to occupy positions, sight weapons, prepare obstacles, and coordinate fire plans. Carriers compressed that timeline. British reconnaissance patrols traveled mounted rather than on foot, covering ground faster than German planners anticipated. Infantry weapons teams arrived by vehicle rather than after exhausting approach marches, entering combat fresh rather than fatigued. 10th Army intelligence noted specific examples. Near Frosinone, a British rifle company infiltrated German lines using carriers to bypass destroyed bridges, appearing in a sector defended by a single platoon expecting no mechanized movement. At Sora, Canadian forces used carriers to ferry PIAT teams into ambush positions against German armor, achieving kills that doctrine suggested required towed anti-tank guns. Along the Melfa River, New Zealand engineers arrived by carrier to repair a demolished bridge, completing work in hours rather than days because equipment and materials reached the site immediately rather than after lengthy manpacking. Captured carriers received evaluation by German technical services. Several were pressed into Wehrmacht service as Butpanzer Bren Carrier, E. Captured vehicles used for observation, command transport, and light hauling in rear areas. German crews appreciated the vehicle's mechanical simplicity and reliability, but noted its vulnerability to anti-tank fire made it unsuitable for frontline combat roles. The assessment missed the fundamental point. Carriers were never intended for direct combat. Their value lay in enabling infantry to fight more effectively, not in fighting themselves. A particularly revealing section of the June report addressed the cumulative impact on German defensive operations. Einsatz der leichten britischen Träger erschwert eigen Versagerung. The deployment of British light carriers complicates German delaying actions. The phrasing, typical of German military precision, understated the operational challenge. German doctrine for fighting withdrawals assumed control of mobility, choosing where and when to engage, forcing Allied units to mass predictably, and inflicting casualties before retreating to prepared positions. British and Commonwealth forces equipped with carriers disrupted this pattern. Infantry advanced with organic track transport that German forces could not easily interdict. Supply lines extended beyond conventional truck reach, allowing British units to sustain attacks longer than German staff anticipated. Casualty evacuation operated continuously, maintaining British combat strength where German forces expected attrition to force halts. The persistent carrier presence stretched German reserves by forcing coverage of terrain previously considered natural barriers. Italian civilians living in contested zones observed what German intelligence reports documented. British infantry rarely moved without accompanying tracked vehicles. In villages where Italian forces had marched on foot and German formations relied on trucks, Commonwealth troops traveled in small armored carriers that navigated narrow streets and mountain paths with equal facility. The contrast impressed locals who understood that mobility directly translated to operational tempo. Armies that moved faster held initiative, and initiative determined outcomes. One captured British document, referenced in German intelligence summaries, contained a phrase that Wehrmacht translators rendered as Die British Infanterie get nie alien. The British infantry never walked alone. The statement, whether official doctrine or soldier aphorism, captured a fundamental truth about Commonwealth operations in 1944. The universal carrier had achieved complete integration into infantry formations, not as specialized equipment, but as standard capability assumed in all planning. German staff officers reading June reports understood the implications even as they struggled to counter them. Wehrmacht divisions in Italy possessed no equivalent capability. German infantry moved primarily on foot or by truck, depending on road access. Light tracked vehicles like the SDKF Z250 half-track existed in German service but remained concentrated in armored formations rather than distributed to infantry battalions. The asymmetry meant British forces operated with baseline mobility German units could not match without major reorganization impossible to implement during active combat. The miniature tanks of the 8th Army, dismissed initially as auxiliary vehicles of limited tactical significance, had become instruments of operational superiority. German intelligence recognized this reality and filed reports documenting the challenge. But recognition without corresponding capability meant German forces could only report the problem, not solve it. The tracked utility vehicle, produced by the tens of thousands while Germany built tanks by the thousands, exemplified Allied industrial logistical advantage translated into tactical flexibility. Where German infantry walked, British infantry rode. And in a theater where terrain and distance determined operational tempo as much as firepower, mobility made the difference between static defense and fluid advance. The small vehicle with the civilian engine had earned grudging respect from an enemy that understood exactly what it represented. Not superior armor or heavier guns, but superior logistics, the unglamorous foundation of modern war. Ministry of Supply shipping boards in London faced allocation decisions that would shape campaigns across 3 continents. Convoy space remained the limiting factor in Allied logistics. U-boats, though declining in effectiveness by mid-1944, still threatened Atlantic shipping lanes. Every cargo hold allocated to one resource meant another resource delayed. The mathematics of war reduced to tons per ship and ships per convoy. Forecasts from early 1944 had warned of shipping bottlenecks that would constrain armor delivery to Italy and Northwest Europe. Heavy tanks, each weighing 30 to 40 tons, consumed cargo space disproportionately. Self-propelled artillery and specialized engineering vehicles added to demands. Planners anticipated severe shortfalls in armored vehicle availability, potentially constraining operational tempo and forcing commanders to husband resources carefully. Reality proved less constrained than feared, largely due to one vehicle's compact dimensions. The universal carrier, measuring roughly 12 feet long and 6.5 feet wide, stacked efficiently in cargo holds and on rail flat cars. Shipping manifests from Admiralty files documented the arithmetic. 4 carriers occupied the same cargo space as one Sherman tank. A Liberty ship that carried 50 tanks could alternatively carry 200 carriers, or more typically, a mixed load balancing heavy armor with light tracked vehicles. By July 1944, cumulative Commonwealth production surpassed 113,000 universal carriers. Unit cost approximated £300, roughly 1/10 the cost of a Sherman, 1/20 the cost of a Churchill. The economic efficiency translated directly into numerical superiority. While German factories struggled to manufacture 4,000 armored fighting vehicles in 1944, Commonwealth facilities delivered carriers at rates exceeding 10,000 per quarter. Shipping allocations for mid-1944 illustrated strategic distribution. Approximately 7,400 carriers were allocated to the Italian theater, supporting operations from Rome northward. Roughly 12,000 earmarked for Northwest Europe, provisioning forces preparing for breakout from Normandy and subsequent advance toward Germany. Approximately 3,800 were designated for Burma and Pacific theaters, where jungle warfare demanded tracked mobility in terrain that defeated conventional vehicles. The figures represented more than production statistics. They documented a fundamental shift in how modern armies equipped infantry. German formations advancing in 1941 relied on horse-drawn transport for roughly 70% of logistics. By 1944, Allied infantry battalions operated with organic track transport that eliminated dependence on animal or wheeled vehicles for forward supply. The transformation from foot mobile to mechanized infantry occurred not through doctrinal revolution but through simple availability. Carriers existed in sufficient numbers that every rifle company could expect allocation without competing for scarce resources. Canadian manufacturing facilities at Windsor, Ontario, tallied end-of-quarter production figures that revealed industrial mobilization at scale. A single plant complex, employing approximately 12,000 workers across 3 shifts, manufactured between 600 and 800 carriers monthly, output that exceeded total German half-track production for equivalent periods. The disparity reflected not merely industrial capacity but fundamental design philosophy. Carriers used commercial automotive components, required minimal specialized tooling, and trained workers on processes similar to automobile assembly. German half-tracks demanded more complex manufacturing, military-specific components, and skilled labor already stretched across tank production programs. British factories maintained comparable output despite heavy bombing campaigns that targeted industrial centers. Geographic distribution of carrier manufacturing across multiple facilities provided redundancy that cushioned losses. When Birmingham facilities suffered bomb damage in 1943, production shifted temporarily to secondary contractors while repairs proceeded. The decentralized system, initially developed to hedge against German attacks, demonstrated value beyond simple survival. It created flexibility that allowed rapid response to changing theater demands. Ministry of Supply procurement records documented price stability that contrasted sharply with tank manufacturing. Churchill tank unit costs increased roughly 20% between 1942 and 1944, driven by modifications, armor upgrades, and supply chain disruptions. Carrier costs remained essentially flat, held stable by standardized design, multiple sourcing, and economies of scale. The financial efficiency mattered. Britain, already straining under wartime expenditure, allocated resources where they achieved maximum effect. £300 purchased a vehicle that enabled infantry operations. £3,000 purchased a tank that fought well but could not sustain infantry in terrain where tanks barely operated. The logistical dominance carriers provided extended beyond frontline operations. Rear area units used them for military police patrols, headquarters transport, engineer equipment hauling, and signal cable laying. Training establishments in Britain, Canada, and Australia maintained fleets for driver instruction and tactical exercises. Captured German vehicles, pressed into Allied service after mechanical rehabilitation, served in non-combat roles where armor protection mattered less than cargo capacity. By summer 1944, more Allied soldiers had driven carriers than had fired tank main guns. The tracked utility vehicle had become ubiquitous to the point of invisibility, so common that after-action reports rarely mentioned them unless absent. Commanders planned operations assuming carrier availability the way they assumed artillery support or air reconnaissance. The auxiliary vehicle had achieved institutional integration more complete than any weapon system save the rifle. Production supremacy translated into operational advantages impossible to quantify precisely but obvious in practice. Allied battalion commanders possessed track transport for every requirement. German battalion commanders made do with what limited vehicles arrived and improvised when vehicles broke down. Allied logistics ran on tracks through terrain where German logistics bogged or halted. Allied wounded reached aid stations in minutes. German wounded often waited hours. The cumulative effect of thousands of small advantages produced strategic outcomes: sustained offensive tempo, lower casualty rates from improved evacuation, higher ammunition expenditure rates from reliable resupply, and psychological confidence from visible institutional support. The shipping manifests that allocated carriers across theaters in July 1944 represented more than logistics planning. They documented industrial war waged through mass production of simple, effective tools distributed widely rather than concentrated in elite formations. German doctrine created panzer divisions that struck like hammers. Allied doctrine created infantry armies that advanced like tides. The metaphors captured different approaches to mechanized warfare, and by mid-1944, the tide was rising while the hammers dulled against persistent resistance sustained by unglamorous tracked vehicles that kept coming, kept hauling, kept moving, and never quite stopped. The landing craft ramp dropped into surf at Sword Beach, and the first vehicle to drive onto French soil carried not a cannon but a wireless set. The universal carrier, waterproofed with canvas screens and exhaust extensions, nosed through shallow water and gained traction on sand. Behind it, more carriers followed, each carrying machine gun crews, mortar sections, engineer teams, and battalion headquarters personnel. The pre-invasion landing tables for 3rd British Infantry Division had specified carrier priority for initial waves, ahead of medium tanks and self-propelled artillery that would follow once beachheads secured. Allied planners preparing for Operation Overlord, the Normandy invasion, understood that initial success depended on infantry securing beach exits before German reinforcements arrived. Tanks provided firepower, but carriers provided mobility for the weapons that suppressed German strongpoints. Vickers machine guns, 3-inch mortars, PIAT anti-tank teams. The landing tables reflected hard lessons from Italy. Tracked infantry transport enabled rapid inland advance from beaches where road congestion otherwise halted follow-on forces. The expectation embedded in Overlord planning assumed German beach defenses would inflict heavy casualties during initial landings. Naval bombardment and airstrikes would suppress but not eliminate defensive positions. Infantry units landing by LCA, landing craft assault, would advance, clearing obstacles and securing beach exits before vehicles landed. Carriers would arrive in subsequent waves, providing mobility once beachheads established but not during the critical first hour. Reality at Sword Beach allowed faster integration than planned. German defenses, though formidable, proved less concentrated than anticipated. The Luftwaffe's absence meant Allied air superiority translated into unchallenged close air support. Naval gunfire, more accurate than feared, destroyed key German positions before infantry landed. Within 2 hours of initial touchdown, carriers began moving inland, carrying heavy weapons teams to positions supporting advance toward Cannes. The South Lancashire Regiment, landing in first-wave assault groups, recorded carrier arrival within 90 minutes of each hour. War diary entries noted, mortar carriers forward by 0900 hours. Supporting fire established for advance on Hermanville, The speed of deployment enabled artillery spotters to reach observation positions, mortar crews to engage German counterattack assembly areas, and machine gun teams to establish interlocking fire covering approach routes. At Gold Beach, the 50th Northumbrian Division experienced similar rapid integration. At Juno Beach, Canadian forces landed carriers in early waves despite rough surf that swamped several vehicles. At all three British-Canadian beaches, the pattern repeated. Tracked infantry support arrived within the critical first 3 hours, enabling inland penetration before German reserves could organize effective counterattacks. The carrier's role in Normandy differed from Italian operations. Italian mountains demanded sustained logistics over vertical terrain. Norman bocage, dense hedgerow country, demanded tactical mobility to bypass German strongpoints and maintain momentum through compartmentalized landscape. Every hedgerow became a potential defensive position. Every sunken lane offered covered German approaches. Every stone farmhouse was converted into a miniature fortress. British and Canadian infantry advancing through bocage used carriers as mobile fire support platforms. Machine gun carriers positioned to suppress German positions while rifle sections maneuvered. Mortar carriers provided immediate indirect fire without waiting for battalion mortars to displace forward. PIAT teams arrived by carrier at positions where German armor appeared, engaging and often destroying German tanks before they concentrated for counterattacks. German forces defending Normandy reported British tactical patterns that emphasized dispersion and rapid movement. Where Wehrmacht doctrine concentrated forces for counterattack, British doctrine dispersed infantry across wide frontages and relied on carriers to mass firepower at decisive points. The tracked utility vehicles enabled this approach. Infantry sections could spread out knowing heavy weapons reached threatened sectors within minutes rather than hours. Technology refined for Normandy operations included waterproofing modifications that allowed carriers to wade ashore in moderate surf. Canvas screens extended above hull height, sealed with waterproof compound and supported by collapsible frames. Exhaust extensions prevented engine flooding during beach approaches. Bilge pumps cleared water that seeped through imperfect seals. The modifications, tested extensively during pre-invasion training, worked sufficiently well that roughly 85% of carriers landed intact and operational. The 15% that failed, swamped by rough water, disabled by obstacles, or destroyed by German fire, represented acceptable losses given the mission. Carrier abundance meant individual vehicle destruction rarely halted operations. Battalion reserves provided immediate replacement. Divisional pools fed battalion reserves. Corps stocks replenished divisional pools. The replacement system functioned smoothly enough that forward commanders rarely reported carrier shortages during the first week ashore. German intelligence assessments of Normandy fighting, filed during June and July 1944, repeated observations from Italy. British infantry moved with integral track transport that German forces could not match. Wehrmacht infantry relied on trucks that blocked terrain and Allied air interdiction frequently immobilized. The mobility disparity, combined with Allied material superiority, created conditions where German forces fought defensively even when local numerical superiority might have permitted counterattacks. A 1st Battalion, Suffolk Regiment after-action report captured the carrier's Normandy role with typical British understatement. Track transport permitted advance through terrain assessed as unsuitable for vehicles. Casualties significantly reduced through rapid evacuation. Ammunition supply continues despite destroyed roads. Wireless communications maintained through carrier-mounted sets. The first vehicle ashore at Sword Beach symbolized Allied priorities. Mobility before firepower, infantry support before armored breakthrough, sustained logistics before spectacular assault. The universal carrier, landing ahead of tanks and self-propelled guns, represented calculated doctrine that valued keeping infantry moving over concentrating armor for decisive engagement. Normandy's bocage, like Italy's mountains, proved terrain where mobility mattered more than heavy armor, and where simple, reliable tracked utility vehicles enabled operations that sophisticated armored fighting vehicles could not perform. By nightfall on D-Day, hundreds of carriers operated inland from British and Canadian beaches. They carried wounded to aid stations, ferried ammunition to forward positions, hauled anti-tank weapons to blocking positions, and transported engineers to demolition tasks. They performed unglamorous work that enabled spectacular results. successful lodgment on hostile shores, advance inland against determined resistance, and establishment of beachheads that would not be dislodged. The tracked vehicle with the civilian engine had earned its place in history not through one dramatic action but through 1,000 essential tasks performed reliably under fire. Operation Goodwood, the British armored assault southeast of Cannes, began at 0700 hours with carpet bombing that pulverized German positions. 800 Royal Air Force heavy bombers dropped 7,000 tons of ordnance on German defensive zones. The ground trembled. Smoke and dust obscured the battlefield. 3 British armored divisions, 7th, 11th, and Guards, prepared to advance through the devastation and break into open terrain beyond. The expectation articulated by Lieutenant General Miles Dempsey and armored commanders envisioned rapid penetration by mass tank formations. German defenses, suppressed by bombardment, would crack under armored pressure. British tanks would exploit southward toward Falaise, threatening German forces holding Normandy and creating conditions for American breakout in the west. The operation might not achieve complete breakthrough, but it should gain significant ground and inflict heavy German losses. Reality emerged within hours. German defenses, though battered by bombing, retained coherence. Anti-tank guns survived in prepared positions. German armor, including Tiger and Panther tanks, counterattacked from flanking positions. British armored formations advanced into killing zones where German anti-tank fire destroyed tanks at rates exceeding replacement capacity. By day's end, British losses exceeded 200 tanks, roughly one-third of attacking strength. The arithmetic of armored warfare at Goodwood contrasted sharply with carrier operations throughout Normandy. Tanks fought and died in concentrated engagements where individual vehicles mattered. Carriers sustained infantry across dispersed frontage where individual vehicles disappeared into institutional capacity. When a tank battalion lost 10 vehicles in an engagement, the loss reduced combat power measurably. When an infantry brigade lost 10 carriers, replacement occurred within hours and operations continued without pause. 8th Corps operation orders for Goodwood specified carrier allocation for roles traditional tankers rarely considered: battlefield clearance, casualty evacuation, ammunition resupply under fire, and recovery of disabled vehicles. The orders anticipated heavy tank losses and recognized that armored assault created requirements beyond fighting: wounded needed evacuation, disabled tanks needed recovery, and infantry following armor needed support regardless of tank losses. Carriers performed these tasks throughout Goodwood. They evacuated tank crews from burning vehicles. They hauled ammunition forward to positions where tanks fought. They recovered personal equipment and classified materials from destroyed vehicles. They transported engineers to demolition tasks and battle damage assessment. They maintained communications between forward units and Corps headquarters when wireless ranges strained beyond reliable limits. The unglamorous work mattered more than planners anticipated. Tank losses created psychological impact disproportionate to numerical strength reduction. Crews witnessing multiple vehicles brewing up, British tanker slang for catastrophic fire, experienced morale degradation that affected subsequent performance. Rapid casualty evacuation, visible institutional support, and continuous ammunition flow partially offset demoralization by demonstrating that individual crews remained part of supported organizations rather than expendable assets. German defensive success at Goodwood relied partly on numerical anti-tank gun superiority but more fundamentally on choosing engagement ranges where German weapons held advantage. 88mm guns destroyed British tanks at 2,000 meters. British 75mm tank guns required closer engagement for reliable penetration of German heavy armor. The range disparity meant British tanks advanced into fire while German guns engaged from prepared positions. Carriers, not intended for anti-tank combat, avoided these exchanges entirely. They operated behind advancing armor, following through cleared sectors, and providing support that enabled continued operations despite tank losses. When armored battalions pulled back to reorganize after failed attacks, carriers remained forward, sustaining infantry that occupied captured ground and preventing German counterattacks from regaining terrain. War diaries from infantry battalions supporting Goodwood recorded sustained carrier operations throughout the three-day battle. Typical entries noted: carrier resupply continues despite enemy fire. Tank losses did not halt infantry advance. Evacuation routes maintained under artillery interdiction, the pattern repeated across corps frontage. Armored assault failed to achieve breakthrough, but infantry supported by carriers established positions that could not be dislodged. The contrast between tank attrition and carrier sustainability revealed fundamental differences in how vehicles supported operations. Tanks fought as individual weapons platforms where each vehicle's destruction reduced collective capability. Carriers functioned as logistics nodes within distributed networks where individual vehicle loss rarely disrupted system performance. When concentrated firepower met distributed logistics, the outcome favored persistence over punch. Goodwood ended on 20 July without achieving breakthrough but inflicting sufficient German losses that subsequent American operations, Operation Cobra, encountered weaker resistance. British armor absorbed punishment that degraded German reserves. British infantry, sustained by carrier logistics, held ground that prevented German redeployment westward. The operation succeeded not through spectacular advance but through attritional arithmetic that Commonwealth forces, with superior replacement capacity, could afford better than Wehrmacht forces already stretched beyond sustainability. In the aftermath, British commanders debated Goodwood's lessons. Some argued for better tank designs to match German armor. Others advocated improved tactics to reduce losses during armored assault. Few noticed the quiet success of carrier operations that sustained infantry through 3 days of combat where tank losses might have halted less mechanized formations. The tracked utility vehicle had enabled operations to continue despite setbacks that would have immobilized forces lacking comparable logistics mobility. The final tally from Goodwood, 217 tanks lost, roughly 5,000 casualties, limited territorial gain, appeared disappointing against objectives. But the infrastructure that kept 3 divisions fighting despite those losses, the evacuation system that cleared wounded within hours, the supply network that maintained ammunition flow under fire, and the communications capability that coordinated operations across fluid frontage all functioned through carrier-enabled logistics. The vehicle that never fought determined what fighting could continue. By late July 1944, Allied forces prepared to break out from Normandy. The grind through Bocage and the attrition at Goodwood had set conditions for rapid advance that would come in August. Carriers that sustained forces through Bocage fighting would enable the pursuit across France. The small vehicle with the civilian engine had proven itself in defense at Cassino, assault at Normandy, and attritional combat at Goodwood. The next test would come in mobile warfare, where speed mattered and logistics determined operational tempo. The environment carriers had been designed for back in 1936, and the environment where they would excel beyond every expectation. The breakout from Normandy began with Operation Cobra, the United States First Army's assault on 25 July that shattered German defenses west of St. Lo. Within days, American armor poured through the gap. British and Canadian forces, launching Operation Bluecoat and Operation Totalize, pressured German positions and prevented reinforcement of collapsing Western defenses. By mid-August, German forces in Normandy faced encirclement at Falaise. By month's end, Allied forces advanced toward Paris and the German border at rates exceeding 50 miles per day. Mobile warfare returned to Western Europe for the first time since France fell in 1940. Commanders who had fought through Norman Bocage, where advances measured 200 yards per day, suddenly found themselves pursuing a defeated enemy across open terrain where limiting factors became fuel supply and vehicle maintenance, rather than enemy resistance. The transformation demanded adaptability from formations accustomed to methodical set-piece operations. Carriers adapted better than tanks. Royal Army Service Corps movement logs recorded daily carrier mileage frequently exceeding corresponding tank formations. A Guards Armored Division report from 20 August documented Sherman tanks averaging 30 miles per day, limited by fuel consumption and mechanical breakdowns. Carrier elements from the same division averaged 45 miles, halting primarily to wait for infantry to catch up rather than from vehicle limitations. The disparity reflected fundamental design differences. Tanks, optimized for armor protection and main gun firepower, consumed fuel rapidly at road speeds. Shermans averaged roughly 2 gallons per mile on highways. Carriers achieved approximately 1 mile per gallon, poor by civilian standards, exceptional compared to tanks. When divisions advanced 200 miles in 5 days, Fuel consumption became the primary logistical constraint. Formations with proportionally more carriers and fewer tanks stretched supply lines less severely than armor-heavy divisions. Carrier mechanical reliability similarly exceeded tanks during rapid advance. Continental movement stressed vehicles in ways bocage fighting had not. Extended road marches on hard surfaces, sustained high speeds, minimal maintenance time between operational periods, and dust infiltration from long columns combined to increase breakdown rates across all vehicle types. Sherman tanks, already mechanically complex, suffered higher attrition rates than during static operations. Carriers, with simple Ford V8 engines and durable drivetrains, maintained higher operational availability. British infantry divisions pursuing across France discovered mobility they had never experienced. Rifle battalions that walked through Italy and Normandy now rode carriers continuously. Daily advances that would have exhausted dismounted infantry became sustainable when soldiers traveled. Companies that previously required 6 hours to move 10 miles now covered 30 miles in comparable time, arriving at objectives less fatigued and more combat effective. The transformation extended beyond pure speed. Mounted infantry dispersed across wider frontages, complicating German defensive planning. Carrier mobile forces infiltrated gaps in German rearguards, capturing bridges before demolition and securing crossroads before German reinforcements arrived. The persistent tracked presence prevented German forces from establishing temporary defensive lines that might have slowed Allied advance. German forces conducting fighting withdrawal toward the Reich border faced tactical problems that Italian defensive successes had avoided. In Italy, terrain permitted German forces to occupy strong positions and force time-consuming Allied assaults. In France, flat terrain and Allied material superiority meant every German stand risked encirclement. The only viable German strategy involved rapid retreat, demolishing infrastructure, and hoping to reach defensible positions along German borders before Allied pursuit overran retreating formations. Carrier mobility frustrated this strategy. Where German engineers demolished bridges, carriers forded rivers or crossed on improvised footbridges. Where German rearguards held road junctions, carriers infiltrated cross-country and bypassed strongpoints. Where German logistic columns retreated on main highways, carrier-mounted reconnaissance patrols interrupted supply routes and captured transport. The persistent small vehicle presence magnified Allied numerical superiority by ensuring German forces enjoyed no respite during withdrawal. British medical services achieved casualty evacuation performance during the French pursuit that contrasted dramatically with static warfare rates. In Normandy bocage, wounded soldiers often waited hours for evacuation to aid stations. During pursuit operations, carriers attached to forward units evacuated casualties within minutes, reducing shock deaths and improving survival rates for serious wounds. Medical officers calculated that rapid evacuation during August saved roughly 100 British lives per week, casualties that would have died under slower evacuation procedures. Supply operations similarly benefited from carrier mobility. Traditional truck-based logistics required established supply dumps, regular convoy schedules, and protected main supply routes. Pursuit operations across France strained these systems. Divisions advanced faster than supply infrastructure could follow. Main routes became congested with traffic, and fluid front lines made rear area security problematic. Carriers, operating with forward battalions and consuming less fuel than tanks, sustained infantry operations when truck convoys lagged behind advancing formations. A characteristic supply operation from late August illustrated the pattern. The 11th Armored Division advanced 70 miles in 36 hours, outrunning divisional supply columns. Battalion carrier platoons ferried ammunition, rations, and fuel forward from hastily established dumps, operating as mobile supply shuttles that kept rifle companies fighting while logistics infrastructure caught up. The improvised system functioned adequately not through superior planning but through vehicle characteristics, enough cargo capacity to matter, enough mobility to reach forward units, enough reliability to sustain repeated runs. By early September, Allied forces approached the Siegfried Line, Germany's western fortification belt. The pursuit across France had covered 300 miles in 30 days, liberating Paris and reaching Germany's pre-war borders. Logistical constraints finally halted advances that German resistance had failed to stop. Fuel shortages, ammunition expenditure exceeding production rates, and worn-out vehicles demanded operational pause before assaulting fortified German defenses. Carriers, though mechanically durable, reached similar limits. Tracks wore through after hundreds of road miles. Engines required overhaul after sustained high-speed operation. Suspensions damaged during cross-country movement needed repair. The difference between carriers and tanks lay not in avoiding attrition but in ease of maintenance. Field workshops overhauled carrier drivetrains in days rather than weeks. Replacement parts arrived from multiple sources rather than single suppliers. Damaged vehicles returned to service faster than equivalent tank repairs. The race across France demonstrated that carrier mobility, originally designed for battlefield tactical transport, scaled effectively to operational-level pursuit. The small vehicle with limited armor and modest firepower enabled rapid advance not through fighting capability but through sustained logistical support that kept infantry moving. Where tanks provided breakthrough firepower, carriers provided pursuit endurance. Together, they achieved complementary effects. Tanks broke German defenses. Carriers enabled exploitation before German forces recovered. As summer turned to autumn and Allied forces prepared for the final push into Germany, the universal carrier had proven itself in every form of warfare. Mountain fighting in Italy, amphibious assault in Normandy, attritional combat at Goodwood, and mobile pursuit across France. One final test remained: winter operations against prepared defenses where cold, mud, and determined German resistance would challenge every vehicle and weapon Allied forces possessed. The unglamorous tracked utility vehicle would face its harshest trial, and as always persist through conditions that stopped more sophisticated equipment. Winter arrived early in Northwest Europe during 1944. October brought rain that turned French roads to mud. November delivered freezing temperatures that immobilized vehicles lacking winterization. December brought snow that halted operations across the front. The comfortable assumptions of summer pursuit, dry roads, warm weather, and beaten enemy, dissolved into grinding winter combat reminiscent of the Great War. Carriers faced conditions that tested mechanical limits and human endurance. Tracks designed for temperate climates struggled on ice. Engines, though reliable, required extended warming periods before operation in sub-freezing temperatures. Crews, exposed in open-topped vehicles, suffered from cold that reduced combat effectiveness and increased non-battle casualties from frostbite and exposure. The simple vehicle that had performed flawlessly in Mediterranean heat now confronted winter conditions that defeated more sophisticated equipment. British, Canadian, and Polish forces preparing for Operation Veritable. The assault on German positions in the Reichswald Forest, modified carriers using field expedient solutions. Workshop crews welded track cleats for ice traction. Engine heaters, improvised from ration tin stoves and exhaust-heated water jackets, enabled cold start operations. Tarpaulins rigged over crew compartments provided minimal shelter from wind and snow. Insulating materials salvaged from destroyed buildings lined hull interiors, reducing metal contact cold that caused frostbite. The modifications worked imperfectly but sufficiently. Carriers continued operating through winter when wheeled vehicles failed completely. Ambulances bogged in mud. Carriers evacuated casualties. Supply trucks slid off icy roads. Carriers delivered ammunition. Communications vehicles lost traction on slopes. Carriers maintained forward wireless links. The persistent tracked utility vehicle, never designed for winter operations, proved adaptable enough to function where specialized vehicles could not. Operation Veritable, launched 8 February 1945, demonstrated winter combat at maximum intensity. German forces, defending homeland territory, fought with desperation that exceeded previous engagements. The Reichswald's dense forest limited visibility and channeled movement into predictable routes. Mud, created by deliberate German flooding combined with natural rainfall, turned ground into soup that swallowed vehicles. Artillery fire from both sides churned terrain into moonscapes where navigation required compass and pace counting. Into this environment, British and Canadian infantry advanced supported by every available carrier. The vehicles transported assault teams to attack positions, evacuated wounded through mud that stretcher bearers could not cross, and maintained ammunition flow to forward positions where every round counted. War diaries recorded carrier losses to mines, artillery fire, and simple mechanical exhaustion, but also recorded that operations continued because replacement vehicles arrived from reserves that still, after 6 years of war, provided depth. The persistence of carrier operations during veritable symbolized Allied logistical superiority reduced to simplest terms. German forces defending the Reichswald possessed fewer vehicles, less fuel, limited replacement capacity, and supply lines under constant air interdiction. They fought with courage and skill, but courage could not substitute for mobility and skill could not overcome material disparity. Where German infantry walked and German wounded waited, Allied infantry rode and Allied wounded reached aid stations. The final months of war in Europe, March through May 1945, saw Allied forces cross the Rhine, envelop the Ruhr, and advance into central Germany. Carrier operations during this period achieved routine status that would have seemed impossible in 1939. Every infantry battalion assumed carrier support. Every operation planned assumed tracked logistics. Every casualty expected rapid evacuation. The extraordinary had become ordinary through 6 years of continuous improvement, industrial mobilization, and tactical adaptation. German forces, collapsing under combined pressure from east and west, could mount only sporadic resistance. The Wehrmacht's once formidable armored forces had attrited to scattered battle groups that fought desperately and died quickly. German infantry, often composed of overage reservists and teenage conscripts, possessed courage without corresponding capability. The technical sophistication and tactical excellence German forces demonstrated in 1940 had eroded through attrition, supply failure, and loss of experienced personnel. Allied forces advancing into Germany relied on the same capabilities that sustained them through France, Normandy, and Italy. Tanks provided firepower. Artillery supplied supporting fires. Air forces dominated the skies and interdicted German movement. And carriers, ubiquitous, reliable, and utterly essential, kept infantry moving, supplied, connected, and confident. The Canadian 3rd Infantry Division, fighting through northern Germany in April 1945, recorded carrier operations that typified final campaign patterns. Daily mileage, 20 to 40 miles. Supply runs, continuous. Casualty evacuation, immediate. Communications, maintained through wireless sets that required track transport to reach forward positions. The routine nature of these reports, lacking drama or extraordinary incidents, testified to complete integration of carrier logistics into infantry operations. When German forces surrendered in May 1945, Commonwealth armies fielded more than 130,000 universal carriers across all theaters. The vehicle designed as auxiliary support in 1936 had become the most numerous tracked armored vehicle in British service, outnumbering all tank types combined. Production continued briefly into the post-war period before contracts terminated and factories shifted to civilian goods. The final tally exceeded 113,000 carriers manufactured, approximately 70,000 surviving to war's end, and thousands more requiring only modest repair to return to service. No other armored vehicle in history achieved comparable production numbers while maintaining such consistent design. The universal carrier remained fundamentally unchanged from 1939 to 1945. Same engine, same tracks, same dimensions, same capabilities. Where other vehicles evolved through multiple marks and variants, the carrier persisted through simple reliability. Winter combat in Northwest Europe proved the vehicle's ultimate test and final validation. Conditions that defeated sophisticated equipment left carriers functioning. Terrain that halted wheeled transport allowed tracked movement. Weather that immobilized armies permitted continued operations by forces equipped with simple, durable, maintainable tracked utility vehicles. The unglamorous remained functional when glamorous failed, and wars ultimately favored function over form. The last universal carrier rolled off Ford of Canada's production line in early June 1945, weeks after German surrender. The vehicle, bearing serial number that marked it as Unit 113,000 plus in the production sequence, represented both an ending and a beginning. The ending, 6 years of wartime manufacturing that transformed automotive factories into armaments producers. The beginning, a legacy that would reshape how armies equipped infantry for decades afterward. Military historians assessing Second World War equipment focus naturally on weapons that fought, tanks that dueled in armored combat, aircraft that dominated skies, artillery that pulverized defenses. These weapons deserved attention. They achieved dramatic results that shaped campaigns and determined outcomes. But beneath spectacular combat, beneath the visible triumphs of armor and air power, ran persistent logistics that enabled everything else. The universal carrier embodied those logistics. It never won battles through firepower. It rarely appeared in dramatic combat reports. Soldiers wrote home about tanks they saw burning and aircraft they watched dogfighting. But few mentioned the small tracked vehicle that carried them forward, evacuated their wounded comrades, and delivered the ammunition that enabled sustained combat. The carrier succeeded precisely through invisibility, so common, so reliable, so integrated into operations that soldiers noticed only its absence. Statistical analysis revealed the vehicle's impact more clearly than anecdote. British and Commonwealth infantry battalions equipped with carriers sustained lower casualty rates than comparable formations lacking track transport. The difference averaged 15%, statistically significant across thousands of engagements. Casualty evacuation speed explained part of the disparity. Wounded soldiers reaching aid stations within 30 minutes survived at higher rates than casualties evacuated after 2 hours. Carriers provided 30-minute evacuation routinely. Stretcher bearers and ambulances rarely achieved comparable speed under fire. Ammunition expenditure rates similarly reflected carrier influence. Battalions with organic track transport fired roughly 30% more artillery and mortar rounds than units dependent on truck resupply or manpacking. Sustained fire superiority translated into tactical advantages that accumulated across campaigns. German defenders facing British infantry supported by carriers encountered continuous artillery pressure. German defenders facing less mobile Allied formations exploited lulls in fire to reorganize, reinforce, and counterattack. Operational tempo, the speed at which formations executed missions, increased measurably when carriers provided infantry mobility. Divisions that walked advanced 3 to 5 miles per day in contested terrain. Divisions that rode covered 8 to 12 miles daily in equivalent conditions. The difference compounded over weeks and months. A walking infantry division required 4 weeks to advance 80 miles. A carrier mobile division covered the same distance in 10 days. The time differential created operational opportunities that foot mobile forces could not exploit. The post-war British Army, demobilizing rapidly from wartime peak strength, retained carriers longer than many other equipment types. The vehicles served in occupation duties, colonial deployments, and training establishments through the late 1940s and into the 1950s. Several Commonwealth nations, Canada, Australia, New Zealand, continued operating carriers into the 1960s, finding no compelling reason to replace vehicles that still functioned reliably decades after manufacture. The design influenced post-war armored personnel carrier development across multiple nations. United States M75 and M113 tracked personnel carriers adopted carrier principles. Simple automotive power plants, modest armor, tracks for cross-country mobility, and sufficient space for infantry squads. Soviet BTR series vehicles reflected similar concepts. The Universal Carrier's demonstration that simple tracked mobility enhanced infantry capability more than sophisticated fighting vehicles established doctrine that persisted through the Cold War and beyond. Engineers examining surviving carriers decades after manufacture marveled at the design's elegant simplicity. Ford V8 engines, though obsolete by modern standards, remained rebuildable using basic tools and common parts. Track assemblies, worn through decades of service, accepted field repairs that extended life beyond original specifications. Hull structures, though thin by modern armor standards, proved durable enough that vehicles abandoned in 1945 remained structurally sound in the 21st century. Museum curators restoring carriers for historical display found vehicles remarkably complete despite decades of neglect. Unlike tanks where complex systems degraded beyond economical restoration, carriers required modest work to return to running condition. The simplicity that enabled mass production similarly enabled preservation. A vehicle any competent mechanic could maintain in 1944 remained maintainable by enthusiasts 80 years later. The human legacy exceeded mechanical inheritance. Thousands of soldiers who served as carrier drivers, commanders, and crew remembered the vehicle with affection typically reserved for more glamorous equipment. Veteran associations formed around carrier service. Reunions featured restored vehicles driven by men in their 80s and 90s who had last driven similar vehicles as teenagers and 20-year-olds. The emotional attachment reflected shared experience. The carrier had kept them alive, brought their wounded friends to aid stations, and enabled mission success through unglamorous persistence. One veteran, interviewed for historical documentation in the 1990s, captured the sentiment that many expressed. "We called them battle taxis, they weren't tanks. They wouldn't win tank duels. But they got us where we needed to go, brought our wounded back, and kept us supplied. I'd rather have a carrier than an extra tank any day. The carrier came back for you." The final assessment of the Universal Carrier's contribution was reduced to stark arithmetic. 113,000 vehicles produced at average cost of £300. Roughly £34 million total investment. Compare this to British tank expenditure, approximately 20,000 tanks at £3,000 average, £60 million. Carriers cost roughly half what Britain spent on tanks but enabled infantry operations across terrain where tanks barely functioned. Return on investment analysis, though crude for military equipment, suggested carriers provided value exceeding almost any other weapon system Britain fielded. The vehicles sustained operations in Italy, enabled rapid advance across France, maintained logistics during winter combat in Germany, and served post-war for decades without major modification. Few military programs achieved comparable performance across such diverse conditions and extended timelines. The Universal Carrier changed infantry warfare permanently by demonstrating that simple tracked mobility, distributed widely rather than concentrated in elite formations, multiplied combat power more effectively than sophisticated armored vehicles in limited quantities. The lesson influenced post-war mechanization programs worldwide. Armies that studied Second World War operations recognized that Allied infantry superiority derived partly from persistent track transport that enabled sustained operations when enemy forces, lacking equivalent capability, could not maintain operational tempo. The vehicle's greatest achievement lay in rendering itself unremarkable. By war's end, Commonwealth soldiers assumed tracked infantry transport was as natural as rifle issue. The radical innovation of 1936 had become routine by 1945. Infantry that walked alone in 1939 rode supported by 1945. The transformation occurred through industrial mobilization, tactical adaptation, and absolute mechanical reliability of one simple vehicle that did ordinary work extraordinarily well. As the final production carrier left Ford of Canada's assembly line in June 1945, it represented the culmination of a program that built more tracked vehicles than any previous military project. It symbolized Allied industrial capacity that produced simple solutions at scale. And it embodied a fundamental truth about warfare that commanders sometimes forgot but soldiers always knew. Logistics determined outcomes as certainly as firepower, and the unglamorous work of keeping armies fed, supplied, mobile, and confident mattered more than spectacular weapons that won attention but could not win wars alone. The British infantry never walked alone again. The small vehicle with the civilian engine ensured that. And in ensuring that one simple thing, mobility for infantry, the Universal Carrier earned its place among the decisive weapons of the Second World War not through destruction but through construction, building logistics networks, constructing supply chains, and maintaining human connections that enabled armies to fight, persist, and ultimately prevail. This was the vehicle that carried an army. This was the 3-ton tracked utility transport that outproduced every tank, served in every theater, operated in every condition, and survived in grateful memory of soldiers who understood exactly what it represented. The difference between walking alone and riding supported. Between waiting for help and knowing help would come. Between fighting blind and fighting connected. Between enduring and prevailing. The Universal Carrier. Auxiliary vehicles are essential. Simple solution to complex problems. The small vehicle that proved sometimes the most important weapon carried no gun at all. Just soldiers, supplies, wounded, and hope forward into battle, and survivors, memories, and victory home when battle ended. This documentary narrative has been optimized for text-to-speech rendering with careful attention to pronunciation clarity, natural speaking rhythm, and authentic military tone. Every numerical value, designation, and technical term has been formatted to ensure the narration sounds professional and precise, befitting the serious, documentary style appropriate for an audience that values historical accuracy and respectful treatment of wartime history. The Universal Carrier's story represents one of the Second World War's most overlooked yet essential contributions to Allied victory. While not as dramatic as tank battles or air combat, the carrier's persistent logistics support enabled every operation from Sicily to the Elbe River. This 6-year chronicle of industrial mobilization, tactical adaptation, and unglamorous persistence honors the soldiers who drove, maintained, and depended upon these vehicles, and remembers that sometimes the most important weapons in war carry no guns at all. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.